Hey guys, horizontal asymptotes. We've taken a look at the vertical asymptotes and the domain. Now we're going to look at the horizontal asymptotes today. The horizontal asymptote, as the word states, is horizontal, left and right. So this is an asymptote. It's going to look like that. So here's the graph of x plus 3 over x plus 2. Do you see a horizontal asymptote? Hopefully you do. It's found right here. It's kind of the break looking up and down on the graph. It's kind of where it breaks from the lower portion of the graph to the higher portion of the graph. Here we have a horizontal asymptote. Now the first thing I want to say is horizontal asymptote is a little bit different than a vertical asymptote. A horizontal asymptote can be crossed sometimes. Whereas remember, a vertical asymptote can never be crossed because you cannot divide by 0. So in the future, we'll see where this happens. Okay, so moving on. Here we have our function f with our polynomial on the top, our polynomial on the bottom. Function n and function d have no common factors, so we're not dealing with common factors yet. It says, if they have no common factors, then the graph of f of x has at most one horizontal asymptote. Okay, if they have no common factors, they have at most one horizontal asymptote. So there's 3 rules that you need to know. Please know these rules. If the degree, remember we talked about that yesterday, if the degree of the numerator, right here, is less than the degree of the denominator, which is happens to be function d. Oh, I just caught that. N for numerator, d for denominator. Ha, good one. Then the line y equals 0, which is the x-axis, is the horizontal asymptote. Very simple. You look at the degrees. If the top degree is less than the bottom degree, then y equals 0 is automatically the horizontal asymptote. So take a look at these 2 examples. The degree on the top is 1. The degree on the bottom is 2. So since 1 is less than 2, the horizontal asymptote is automatically 0. Okay? Look at example number 2. Here the degree is 2 and the degree is 3. So 2 is less than 3. So the horizontal asymptote is y equals 0, which is the x-axis, which is right on the x-axis, right here. Okay, notice on this one the degree is 1 and the degree is 1, so this is not the case here. Okay, let's look at the second rule. If the degree of the numerator, the function in the numerator, is equal to the degree of the function in the denominator, then the line y equals a over b is the horizontal asymptote. Okay, so well, what's a over b? A is the coefficient of the highest powered variable of the numerator, and b is the coefficient of the highest powered variable of the denominator. Now remember, coefficient means the number in front, the number that's being multiplied times the variable. So let's look at some examples. So first of all, the degree of the numerator is equal to the degree of the denominator. So in this case, 1 equals 1. So since the degrees are the same, we take the numerator, the coefficient on the numerator, 2. That's going to be a, so a equals 2. And the coefficient on the denominator, so b equals 3. And we plug those in for a and b. So our horizontal asymptote will be y equals 2 over 3. Okay, let's take a look at this one. This one, the degree is 2. The degree is 2. Okay, so they're equal. So 2 equals 2. So that means that a is 6 and b is 3. So we would put 6 over 3. Well, 6 over 3 is just 2. So this would be our horizontal asymptote. Y equals 6 over 3, which is 2. Okay? Let's look at another example. Let's say we have let's say we have this. Okay, so looking for the degree. The degree is the largest exponent. So 6. We're looking for the degree is the largest exponent, which is 6. So the degree is the same. Okay, so 6 equals 6. So y equals a over b is going to be our horizontal asymptote. Remember, a is going to be the coefficient on the variable with the largest exponent, the degree. So a is going to be -3, and b is going to be 2. Remember, they're going with the highest exponent. The coefficient is the number in front. So our equation, our horizontal asymptote will be y equals -3/2. Okay, rule number 3. If the degree of the numerator, the function in the numerator, is greater than the degree of the function in the denominator, then the graph has no horizontal asymptote. So the degree is 2, the degree is 1. So since 2 is greater than 1, there is no horizontal asymptote. You will not put any lines like that. No horizontal asymptote at all. Okay, so let's look at this one. 4 is greater than 1. 4 is greater than 1. The degree is 4, the degree is 1, so there's no horizontal asymptote. So those 3 rules, guys, you have to memorize. So let's look at some examples. So you need to know the degree, and you need to know the rule. So in this case, the degree is 3 and 2. Well, 3 is greater than 2. All right, I don't remember. Let's go look. Let's see. No, that's less than. No, that's equal. Greater than. No horizontal asymptote. Got it. Okay, got to remember this. Greater than. None. None. Okay, next one. Let's see. The degree is 1. The degree, 1. Okay, 1 equals 1. Okay. Well, it's not none, because That would be a greater than, equal. I forgot. Man. Okay, equal. Okay, equal. Oh, yeah, I remember. A over B, that's the coefficient of the highest over the coefficient. Okay, got it. So I need the coefficients. So the coefficient on this one is a 2. The coefficient on this one is a 1. So my horizontal asymptote is y equals 2. This is easy. I think I'm getting this. Okay, number 3. The degree on the top is 1. The degree on the bottom, 2, 1, 2. Okay, so 1 is less than 2. Okay, so we got less than. So this was greater than was none. Equal was A over B. Okay, man. What's wrong with my memory? I just read this. Oh, yeah. Less than. Okay, y equals 0. Y equals 0. Good. Well, that's easy. That's easy. Y equals 0. Oh, no. Oh, Mr. Kramer, what was the degree for this one? Oh, my goodness. Oh, my goodness. Oh, yeah. 0. Because if I put an x here and put a 0 on it, x to the 0 power is 1. And 1 times 3 is 3. So there's an x to the 0 here that I just don't see. So 0 and 1. So 0 is less than 1. Less than, we just did that one. Y equals 0. Cool. All right. Let's see what we got here. Find the domain. I know how to do that. Vertical asymptotes, I already know how to do that. And the horizontal asymptote. Oh, cool. I'm going to do this. I'm going to let you guys do this for class. This one. And don't forget to factor on number 6. And number 6. Ooh, yes. Ooh, yeah. Number 7. Good deal. Don't forget to factor the numerator, even though we're not going to be using those factors yet. Okay, and let's do one of these. Identify the horizontal and vertical asymptotes for each of the rational functions graphed below. Okay, so I'm going to go ahead and do my vertical first. So I'm going to go along here. I'm going to go along here until I come to right in between. So, okay, so here the line is here, so maybe I should stop right here. Let's see. Looks like it's getting close to this. Okay, but it looks like it's getting close to that. I'm thinking that maybe it's going to be like right in the middle. That's what's tricky. Tricky. Let's see, what's that? -1, -2, -3. This one looks like it's getting closer to -3. This one looks like it's getting close to -1. So I'm going to go with right directly in the middle, which is wait a minute, -2, sorry. This one's getting close to -2. I think I'm going to go with -2.5. That one was tricky, because there's quite a good sized gap in here. So I'm going to go directly in the middle. Vertical asymptote. All right. Not vertical. I'm sorry. Oh, I did that one wrong. Sorry. Put in the wrong spot. Tricked me. So, trickster. By the way, who's going to win the Super Bowl next year? Right, the Vikings. So this one's going to be up 1, 2, 3. So y equals 3 is going to be, looks like a good spot. Oops, dash line. Don't forget to do your dash line. See you tomorrow.